Hey everyone, this is Miss Gibbs again. I wanted to go through a chapter 5 problem with you to make sure that everyone is okay with the way that they are working the problem out. Okay. So I am in your e-text from my stat lab. I just pulled up chapter 5 quiz and I just pulled one of the problems. So here is the problem that we're going to be working on. In a standardized IQ test, scores are normally distributed. Remember, normally distributed is letting us know we're using some type of table for normal CDF, Excel, something. Um, Especially if it's asking us for probability, area percent. With a mean score of 100 and a standardized deviation of 15. Use the information in exercises 3 through 10. So we're going to just look at number 3. Find a probability that a randomly selected person has an IQ score higher than 125. Okay, so let me switch screens real quick. And let's go work this out, at least set it up. So the mean is 100. Try to write a little bigger. The standard deviation, the population standard deviation is 15. So we all set it up the same way. You don't have to graph, but the graph will kind of let you know how you're working this out, what your answer should be at least. So in the middle, we have our mean, 1 standard deviation, 2 standard deviations. Going to subtract 1 standard deviation. This should be 70. Okay. So for A is stating greater than 125, I believe. Let me flip back over real quick. Higher than 125. So 125 is probably about right here. That's higher than 125. So we're all setting it up the same way. And then you're going to click on your bookmark to whichever way you're going to work this out. I'm going to go over the calculator first because most of y'all use the calculator. So according to the problem, it says find a probability. I know that I'm using normal CDF. So way A is the calculator. If you don't like the calculator, just skip ahead. Now I'm going to look at my graph to tell me what I'm putting in the calculator. So my left boundary, or my lowest number, is 125. Highest number, I don't have one, so I have to make up one. 10,000 is usually enough for us to tell the calculator to stop working. So normally that's good enough, 10,000. If it's not big enough, because this number has to be bigger, just make it 100,000. Okay. Then I'm going to put in my mean because I have a mean. And then I'm going to put in my standard deviation. This is the calculator. Try to darken this up so you can see it. So that's second vars, normal CDF. This is the lowest the calculator will go. If it was negative 10,000, we could leave that in there. But we don't have a less than. So we have 125 greater than 10,000. 100 for our mean. Standard deviation 15. So our answer is 0.0478. We need 4 decimal places. 0.478. Now for the table, meaning you like to use table 4. If you're using table 4, remember we have to convert our x to a z-score. We have to convert our x to a z-score if you're using a table. And because it's greater than, we're going to have to do 1 minus our area that we see on the table. And I'll show you how it's not matching, so you have to do 1 minus. So z equals x, which is our x that's given, minus the mean over standard deviation. So that's going to be 125 minus 100 for our mean over standard deviation. Just be careful when you're putting this in the calculator to put it in the correct way. So this is 125 minus 100, enter, divided by 15. Gives us a z-score of 1.67. As a reminder for the table, we use 2 digits because our table has 2 digits. So let me get out my handy dandy table. I got that formula for my chapter 5 formula sheet as well, just in case you forget. This is a positive z-score, so I'm going on the right side. So 1.67. 1.67. So 1 minus 0.925. I'm doing 1 minus because notice our graphs don't look the same. See how it's shaded on the right here, and mine's shaded on the shaded on the left here, and mine's shaded on the right. That means I should be taking 1 minus what I see. Again, my graphs aren't shaded in the same direction. So that prompts me to do 1 minus. 1 minus 0.9525. So slightly different answer. Slightly different. Now C, we're going to use Excel. And let me switch my screen over. So now we're in the Excel screen. Anywhere on your, spreadsheet, you can just hit either one, any of them. You're going to go to your function, or if you know what function you're going to be using, you can go there. I pretty much have them memorized, but if you don't, they're under statistical, and then you're pretty much going to look for what you're trying to do. So we're using normal distributions. So normal distribution, this is when we have our x values, and this is when we have our standard normal distribution. Standard normal is in x. So I'm going to hit OK for normal distribution. My x value was 125. Our mean is 100. Our standard deviation is 15. And we're going to write true because we always do the CDF for normal distribution in this course. And this gives you the actual area. So now you have to decide if this is going to be like the table. You have to decide if it's going to be on the right side, and it is on the right side. So you could have either put in 1 minus right before that, or I normally do 1 minus, well, equal sign, 1 minus, and then I just hit that cell. 1 minus whatever I just came up with. So that gives us 0.0478 as well. So with Excel, we had to do 1 minus our B2 or our Excel. 0.04, I believe it was 78. Let me switch back over real quick. Yep, 78. Okay, so hopefully this helped you with your process of completing your normal distribution problem.